Hi everyone, today we're going to look at chapter 10, which is all about the internet. We're going to look at the internet from conception to the current state of the web, and then I have a few short videos that I will make available on Schoology for you, and the links will be on the slideshow if you download it. So let's start with the definition. What is the internet? I'm assuming that everyone in class has had at least some exposure to the World Wide Web, which is made up of a diverse set of independent networks interlinked to provide its users with the appearance of a single uniform network. So what does that mean? This was the definition put out by the National Panel on the Future of the Internet. This diverse set of independent networks starts with a link from your computer to an internet service provider, or ISP. My ISP at home is Knology, but there are a lot of different options available for an ISP. The ISP links you to the internet, which is connected to servers and individual computers all over the world. The information coming in and out of your computer is pushed along fiber optic and other high-speed data lines, and it's presented to you and everyone else in a uniform way that makes it easy to search and find and transmit information. The internet is a mass medium that has elements of interpersonal, group, and mass communication. On the web, we are not only consumers, but prosumers. So it's a revolving door that allows interactions and communications to happen in endless patterns and connection points. So how did this revolutionary communication tool come about? Like most great inventions, it began as a solution to a smaller issue. How do we make incompatible computers talk to each other, share information, and keep communication lines open and available in the event of nuclear war? There were researchers throughout the world working on these questions as early as 1960. So before we even landed on the moon, the internet was being conceived. So one of the first developments was packet switching. In 1957, there were a lot of changes in computing, which set up the framework from which the internet was born. In 1964, Paul Baran was designing a military communications network that could survive if there was a nuclear attack. Baran saw a flaw with our telephone systems that were used at the time because they depended on central switching hubs. So if a bomb took out a hub, communication would stop. So Baran developed a decentralized computer network, and his idea was that if you had many computers on a single network and each was equal, then if one computer was disabled, the message could then be rerouted through the network in a different set of computers and still continue to be sent. He then developed a way for this communication to happen, utilizing the computer's capability to break things down and reassemble them. And these were called data packets. So messages were broke down into smaller packets and sent individually along separate lines. And if there was an interference, the message could be rerouted. When the computer on the other end received the message, it would reassemble them into the original form. The Air Force was interested in building this communication system, but then AT&T decided that they would not cooperate. And their refusal to relinquish some control over long-distance telephone service resulted in Baran's plan being put on the back burner for a while. So during this time that his idea was on the back burner, Donald Davies comes up with a similar plan in England, and Davies gave packet sharing its name. So the difference was that Davies was not developing his technology for the military, but for civilians to communicate in Britain. So here's a graph showing the idea for packet sharing, one of the precursors to the internet. And if you look at the graph, both computer A and B are sending and receiving messages, but computer A is breaking down those messages. So it's A1, A2, A3. They're all going along separate routes, and they go through these hubs. But if one of those hubs was taken out by nuclear war, you could still send the message along another route and it would still get to computer B, which would reassemble it back into its original form. So even though this idea was not implemented by the US military, a packet switching system did eventually get developed, and this was known as ARPANET. The Advanced Research Projects Agency, a division of the Pentagon, was headed by J.C.R. Licklider, and he was a psychologist, but had envisioned a huge teleconferencing system that would join academics, researchers, and organizations, and he had absolutely no idea on how to create such a thing. He decided to name it the Intergalactic Computer Network and sought its creation by people who were in the know and could put this together for him. In 1968, he commissioned BBN, or Boston-based consulting firm, to build the network under the condition that they could complete it in 1 year. So they were able to create a system where incompatible computers could be hooked together and send and receive messages from one another. And by the fall of 1969, a few months after we landed on the moon, BBN got ARPANET online and connected packet switching networks between UCLA, Stanford, USC Santa Barbara, and the University of Utah. And nobody really noticed or saw the importance of the system at the time because it was kind of overshadowed by the amazing feat of NASA landing on the moon. ARPANET expanded to other universities and new networks were formed through radio transmission and satellite, and all of these networks worked really good within themselves, but they could not connect to other networks outside of them. So this was the next revolution, how to link all of the packet switching networks popping up to each other. So Bob Kahn and Vince Cerf created a kind of translator that would allow the networks to communicate with each other. And this translator is known as a protocol, or a common set of rules. Kahn and Cerf called their rules TCP/IP, or Transmission Control Protocol. And TPC controlled how data are sent out on the internet. And then IP, Internet Protocol, assigns an address to each computer. So with a set of rules for sending data and addresses to receive data, the computers in various incompatible networks could communicate if they used this new type of translator. So the original specifications for the internet were published in 1974, before the development of the World Wide Web or browsers, etc. ARPANET was used by academics, and then non-academics became interested in the communication abilities of computers, and then this led to the development of new applications and computer sales. The concept of the internet came from a desire to share resources, but one of the first widespread uses of the internet was for interpersonal communication, because it turns out that people are interested in people. So electronic mail, or as we have all come to refer to it, email, was developed as a way to send a message person to person across a computer network. It took Ray Tomlinson about 3 weeks in 1972 to develop the software that allowed messages to be sent in this way. The software went out over ARPANET and everyone started using it. Tomlinson was also responsible for the @ symbol that we use to tell a computer where the message is, where to send a message or where it's coming from. As the World Wide Web was developed and grew throughout the 1990s, email has remained one of the most important applications on it. And then IM, or instant messaging and chat, was developed and popularized as a real-time email that allowed people to communicate in real time to more than one person at a time. Until the 1990s, the internet was pretty much unusable except as an email machine, because even though there was tons of information on there already, it was difficult to access it because it was just a big, unorganized mess. So enter British physicist Tim Berners-Lee. He invented the World Wide Web, and Berners-Lee built on the ideas of other internet developers and created a system that used common web items such as URL, HTTP, and HTML. So Berners-Lee had an idea for the web based on a book that he saw in his home as a child. It was a Victorian era advice book titled Inquire Within Upon Everything. And he wanted to create a book, or a computer in this case, that contained anything you wanted to know about anything. So a single global information space. His first attempt was in 1980 with a program called Inquire, which organized the lists, documents, and projects on his own personal computer. The program used hypertext, which had been developed earlier by Ted Nelson, and hypertext links allow readers to move from one section to another within a document or from document to document. And nowadays we kind of understand them as web page links. But this hypertext program, Inquire, allowed people to access any documents within their own computer. He then expanded this idea to linking to computers outside of his own and eventually to almost every computer in the world. Hence, the World Wide Web software was written by Berners-Lee in 1989 based on the Inquire software. And by 1990, the European Organization for Nuclear Research, where Berners-Lee was employed at the time, went online with the first web server and simple browser. And he then gave the software away for free in 1991 because he was convinced it was a great idea and he wanted to share it, and it spread from there quickly. So Berners-Lee's breakthrough of the World Wide Web has three major components. URL, or Uniform Resource Locator. We know these as web addresses. HTTP, or Hypertext Transfer Protocol. This is the translator, or the set of rules used for sending information over the web so that incompatible computers can read it. HTML, or Hypertext Markup Language, is the programming language used to talk to the translator. So this language has been made more and more efficient through the years. We now have XHTML, cascading style sheets, HTML5, and other programming languages that help developers and designers design websites and make them appear in uniform ways on almost every browser. And as the web has grown, these elements get more and more complex, but are still based on this basic three-component system. And the concept is the same. You link any computer to any other computer in a way that is decentralized, giving the system the ability to scale or grow indefinitely and still work like it was supposed to. No central point of dissemination is also one of the most revolutionary parts of the internet. It makes it different from mass communication tools we've ever had or seen in the past. The web is based on some key principles. One address takes users to a document. This is your uniform resource locator. Everything is accessible and linkable. This is hypertext. Any data should be available on any computer. This has to do with compatibility, the language that we write things in for the internet. Interaction instead of just publishing. So no longer are we just passive consumers of media. We can create and interact with that media. Decentralized points of communication. There's many sources. And like I said, that's one of the most revolutionary parts of the web. So before 1993, mostly universities and military people who had been using ARPAnet were now using the internet and the World Wide Web. But three things happened in the 90s which flung the tool out into the hands of the public. The code for the World Wide Web was posted to the internet for free. Commercial users were allowed onto the net for the first time. And then the first easy-to-use web browser was created, Mosaic. Mosaic was created by a group of student programmers led by a man named Mark Andreessen, who later pioneered Netscape. And what Mosaic did is it just made it easier for information on the internet to be located. And it created an incentive to post things on the internet. And this software was also given away for free. Andreessen created Netscape Navigator with Jim Clark as a commercial venture. It was given away free to the public, but companies were required to purchase a license for it. The internet began to grow, and by around 1995, 65 million people were using Netscape to navigate the web. And then Microsoft developed Internet Explorer browser in the mid-90s. So internet connections started to change from narrowband to copper telephone wires to broadband, which is actually 10 times faster than dial-up connections through phone lines. And now, with the increased use of wireless, the internet has expanded to mobile devices, including like phones and iPads and laptops and PDAs. So the internet has really just become part of our daily lives, where media has converged. Every type of media that we look at or see has been converged into one space. And it's essentially a book that has almost any information that you could want to know. So I have a link here for a film, which I will make available on the Schoology site, and it's just a graphic representation of the history of the internet, and it just kind of shows how it works very simply, and I like that. So I'll make sure that's available to you. Video games were not always considered a mass media, with the addition of advertising within them, online games, and the stars that have emerged. It has definitely joined the mass media club. Modern game consoles are also media content devices where we can download movies and music and other mass media content from the internet with them. They're essentially computers. The characters within the games have become pop icons, and many have even had their own television shows and cartoons and movies. Landscapes, commercials, even clothing for your gaming characters advertise real products. Even President Obama advertised in video games during his first presidential election, and he was the first president in history to do so. Games can be even more profitable than movies when they come out. Masses of people line up to get the latest copy of a game. And they're also a major element of media synergy. Many films and books and TV shows come out with a game that's based on them. Also, online gaming like World of Warcraft bring together mass amounts of people in a shared experience. So games have moved from being a group or an interpersonal communication to a mass media instead of just a mass product like they were in the past. One of the greatest innovations of the web is its ability to democratize information, and it gives everyone a voice, and it really levels the playing field for accessing information. It removes gatekeepers of knowledge and allows everyone with access to a computer to be a publisher, a consumer, or a creator. Sites like Wikipedia contain information and are populated by people like you and me. And that's why it's a really great source to begin learning about a topic, but it's not a good place to end your research. There can be mistakes and opinions added in there, unchecked by the varied panel that goes over Wikipedia entries. Weblogs or blogs are a place for any individual to communicate anything they wish. They can be a collection of photos or commentary or links to other sites or news or activism. And then Web 2.0 allows users to interact and collaborate with each other in a social media dialogue as creators or prosumers. It's user-generated content in a virtual community, in contrast to websites where users are just consumers and are limited to passive viewing of content that was created for them. Examples of Web 2.0 include social networking sites, blogs, wikis, video sharing sites, hosted services, web applications, and mashups. So I have a link here for a Web 2.0 library. Basically, it's called Go to Web 2.0. And there is a plethora of sites on there where you can interact and be part of a community, which I will put a link to that up. So if you want to check out some Web 2.0 sites or examples. The spreading of access to having a voice on a mass scale has lended itself to citizen journalism, which is news created by people other than professional journalists through sites like YouTube and blogging. And even, many times citizen journalism is featured on mainstream news like cell phone videos on CNN. And now with interactive social networking sites, it's increasingly easier to spread a rumor or an idea through many people at lightning speed. And think about how Facebook changed the world, that video that we watched earlier in the semester. That was primarily cell phone footage spread through Facebook, which caused a spreading revolution that changed governments. And it's still continuing today with the current situations in Africa. One of the things that has helped shape the internet as we know it today is this thing called the hacker ethic. Hacker was originally a term used to refer to computer programmers who like to use computers to their fullest potential. And many times these same people would end up being digital trespassers. Steve Jobs really exemplified the hacker ethic when he was talking about him and Woz building the blue box that allowed them to make free long-distance calls by bypassing AT&T's system. And what he stated was that the incredible lesson that they learned was that they could build a little thing that controlled a giant thing. And that's basically the hacker ethic, or the values that were established in the early days of interactive computing. So I'm going to go through some of these ideas. Access to computers should be unlimited and total. And this is to say that anything that can teach you about how the world works should be available to them, or you, or if you're a hacker, I suppose, or have the hacker ethic. And rules that keep hackers from these things are not respected. All information wants to be free. All information should be available to anyone who wants to make use of it, regardless of copyright laws. This idea of universally shared information was the concept behind Berners-Lee, his World Wide Web. And this ethic, or this point, is just that we should be able to share and use all the things on the web. Mistrust authority and promote decentralization. This is the idea that the best way to keep information from being hidden or controlled by giant bureaucracies is to keep it out in the open or expose it to the public. People should be judged by skills. Basically, a separate identity can be created on the web, and we can say we are another person entirely, and so who we are really matters a lot less than our skills on the internet. The word cyberspace comes from the word cybernetics, Greek for pilot or governor. It was originally used by writer William Gibson in a story that he wrote for a magazine in 1982, and then later in a novel called Neuromancer in 1984. And he used it to describe a ubiquitous, non-physical place where increasingly a lot of what we think of as our civilization takes place. He also coined the phrase cyberpunk, which is basically writing about humans and machines. Although we think of the web on a global scale, in actuality, it's only about 32% of the world's population that has access to the internet. It's more common in developing countries and in higher income areas. And this difference in accessibility to the internet is known as the digital divide, which includes elderly, poor, and rural areas. Mobile access to the web is bridging the gap with cell phones and handheld devices and different ways of accessing the internet. And I have another link here to a video called We Are All Cyborgs Now. And this is Amber Case. She's actually a cyborg anthropologist, so she's studying the relationship between society and humanity, basically, and the machines that we use every day now. And then I will also have another link to a video called 5,000 Days of the Internet, and it is a gentleman talking about the short history of the internet, what's happened in that time, and what could possibly happen in the next 5,000 days. And It is insanely interesting, and I recommend that you guys watch every video that I put on for this chapter because they're all really interesting and will help you understand the content. So let's look at your review questions for this chapter.